Hello, we're looking at example 2 found on page 70 of your pre-calculus part 1 textbook. This is lesson p-6, which is talking about rational expressions. In example A here, it is x cubed plus x squared over x plus 1. Now, if you look at that at first glance, there's nothing that can actually reduce or simplify, as we call it. And so what you have to do sometimes is you have to factor anything that can be factored, and then maybe the other factor that is left can sometimes then cancel out. So we're going to look at the solution for this particular problem. Notice that x cubed plus x squared, I can factor out an x squared, which is going to leave me with x plus 1. Now, the bottom was already x plus 1, so we're just going to leave it as is. What you're going to see here is that this cancels with this. The x plus 1s, because one's in the numerator and one's in the denominator, then they both end up canceling. And so really all you're left with is the x squared here, which is why your answer is x squared. However, when we're dealing with rational expressions, we always have to give the denominator can never be 0. And so whatever would create or cause the denominator to be 0, we also have to include that as an excluded number. And so if we look at the first one, we can see that if we set x plus 1 equal to 0, then x would be negative 1. That means if x were negative 1, it would create 0 in the denominator. So this is why x cannot be negative 1, has to be listed as what is called an excluded value. Okay. Now let's look at part B here. When you look at part B, we're going to factor x squared plus 6x plus 5. Now from previous sections, even in earlier sections, we went over again how to factor a trinomial. You're looking for factors of 5 that add up to be 6, which happen to be 5 and 1. So that's why it factors into x plus 5 and x plus 1. You have to be pretty good at factoring to be able to rationalize or simplify rational expressions. The bottom is called the difference of two squares. You have x squared minus 25, which always breaks down into x plus 5 and x minus 5. Well, when I factor all those out, as you can see in the solution here, the x plus 5s cancel each other because you have one on top and one on bottom, and that always cancels. That leaves you with what's left, which is the x plus 1 on top and the x minus 5 on the bottom. However, for our excluded values, we don't wait till the end to look at excluded values. We look at the beginning, which is this right here. This is how we get that x cannot be negative 5 and x cannot be 5. Because if either one of those were placed in either one of the things, you could end up with a 0, and we don't want that because having a 0 in the denominator is kind of a mathematical no-no, so to speak. It causes the answer to be undefined. So we don't want that. All right, so let's do a couple of these on our own. If I look at the first one, again, I can factor out an x squared, which is going to leave me with x plus 3. The bottom cannot be factored. It's still just x plus 3. However, when I do factor the top, I can see that the top and the bottom are going to completely cancel out, and I'm simply just left with x squared. But, again, I have to put my excluded value, and that comes from this up here. Okay? So if I were to set that equal to 0, then x cannot be negative 3. And you always have to list your excluded values, again, when you're dealing with rational expressions. The second one, I'm going to do it sideways here since I have the room. This turns into x plus 1 and x minus 1. And then the bottom, again, you're looking for factors of 1 that add up to be 2, which happens to be x plus 1 and x plus 1. All right? Now, when I do that, when I completely factor this out, first of all, real quickly, I want to show you that these are both the same. So in the end, I know that x cannot equal negative 1 because that would cause the denominator to become 0. And since those are the same, there's no sense listing it twice. Once would be enough. However, I also want you to notice that the x plus 1's cancel, so my final answer is left as x minus 1 over x plus 1. There's my answer. There's my excluded value. I hope this was helpful.